Today we're doing 4.2, again staying in the same section, and the goal is to use the properties about the unit circle. So for this lesson, you should have your unit circles handy. We're going to be referencing the unit circle throughout the lesson today. So if I ever say you need this coordinate from the unit circle, that's when you should have your unit circle. So the first set of identities that we're going to talk about is the even and odd identities. So there's even and odd identities, reciprocal, quotient, and Pythagorean. So we're going to start with the even and odd. So these are our even and odd identities. And just like it is critical that you know what sine, cosine, tangent, cosecant, secant, and cotangent are, you must also know the even and odd identities. So all of the identities that I'm going to be giving you must be memorized. It is critical for your understanding that you know all of them. So the even and odd identities tell us how to handle negatives. So the even identities is cosine, and this means if I put a negative angle, so let's say my theta is negative, into cosine, it will come out as being a positive cosine. Now, since this is true for cosine, this is also true for secant, because cosine and secant are lined up. They're the reciprocals of one another. So if I input a negative theta into secant, I get a positive secant theta. So those are your even identities. The other four are the odd, and they have a different rule. So if I input a negative theta into sine, the rule says that the negative goes out front of your final answer. So the angle is no longer negative, it's the trig function itself that is negative. If it's true for sine, it's true for cosecant. So cosecant of a negative angle, again, negative goes out front, and the angle is now positive. This is also true for tangent. So again, the negative goes out front. And lastly, it's true for cotangent. So cotangent of negative theta is equal to negative cotangent theta. So we're going to do a few examples to discuss how to use this, and then we'll move on to the next set of identities. So for our first example, the directions say find the value of the trig function. So find the value of the trig function. I'm only going to write these directions one time. I suggest you do the same. Just write it one time and put all your examples underneath this heading. So they want you to find cosine of a negative pi over 4. So looking at your unit circle, notice none of our angles are negative on the unit circle. They are all positive. So the way we go about this is we use the rule I just gave you. Cosine of a negative angle, it's an even function, which says it's the same thing as cosine of a positive angle. So the negative goes away. So now I look at pi over 4 in the unit circle, which I have a coordinate 4, and the coordinate is root 2 over 2, root 2 over 2. So I use the even odd function to get rid of the negative to figure out what angle we're using. Based on that angle, I found the coordinate. Now I need to say, well, cosine is x over r. And since it's from the unit circle, I notice the radius is 1, and that's the x part of my coordinate. So the final answer is root 2 over 2. So let's try another one like that. So again, keep the directions. We're just going to build off of this. So the next problem is tangent of a negative 7 pi over 6. And again, you have positive 7 pi over 6, but there's no negative, so we use the rule. And the rule says this is an odd function, Negative goes out front. So I'm going to move that negative out front, and now I'm working with a positive 7 pi over 6. And based on that coordinate, so based on that angle, I know the coordinate is negative root 3 over 2 and a negative half. Okay, so that 7 pi over 6 tells us the coordinate to use. Now I have to know that tangent is y over x. So notice the negative stays out front, and that's from the original negative. We moved that front. And tangent's y over x. So I have a negative of a negative 1/2 over a negative root 3 over 2. So right now, I know there's a lot of negatives. There's 3 negatives, so you know the overall answer is going to be negative. Negative divided by negative is positive. Times that negative out front, we're going to have a negative answer. Fraction divided by a fraction, I need to do the keep change flip. So I keep the top, and I'm going to flip the bottom to be a 2 over root 3. And again, I drop those negatives because I know if I have total of 3 negatives, the final answer is going to be negative. So these two essentially kind of canceled themselves out. So now I'm at a negative 2 over a 2 root 3. I know these 2's are going to cancel. So now I'm at a negative 1 over root 3. And now you have to rationalize, and that's multiplying by root 3 over root 3. So my final answer, this is a little sloppy, I apologize, is negative root 3 over 3. And that's our final answer. The last thing I would like to do on this video is give you the next set of identities, and then in the next video we'll actually use those identities. So, next set of identities is the reciprocal. So this is your reciprocal identities. And you might have been able to figure these out already. It's pretty obvious once I start writing it down. So, if sine of theta is given, it is the reciprocal of cosecant, which just means 1 over cosecant. Cosine of theta is 1 over secant of theta, and tangent of theta is 1 over cotangent of theta. And then the other 3 follow in the same fashion. So if we have cosecant of theta, that's the same thing as saying 1 over sine of theta. Secant of theta is 1 over cosine of theta. And cotangent of theta is 1 over tangent of theta. So these are our reciprocal identities, and we're going to do a little bit more with these in tomorrow's video. Last thing I would like to give you is the quotient identities. And the word quotient means you are dividing in some shape, way, or form. So 2 of the trig functions can be represented by dividing 2 other trig functions. So tangent is 1 over cotangent. That's one way to define tangent, but another way to define tangent is sine of theta over cosine of theta. And to kind of prove to you why this works, I know sine is y over r, and I know cosine is x over r. And now I have a fraction divided by fraction. So if I keep change flip, if I did y over r times r over x, notice these r's are going to cancel and I'm left with y over x. And y over x is what tangent is equal to. So that's how that proportion works out. And then I know that tangent is the reciprocal of cotangent. So to kind of follow up on that last slide, if tangent is sine over cosine, that means cotangent is cosine of theta over sine of theta. So those are the only two quotient identities. So I'm going to pause with that today, and we're going to pick up on examples on how to use those two sets of identities in tomorrow's video.